This is a quick view of the images and PDFs provided for problem number 1. There are 13 different PDFs. The first PDF is just the answers for part A, B, and C. So here's the setup of the problem. This is the first equation. Calculate the slope of the first equation. And then part A is just writing an equivalent equation, so there's an infinite number of solutions. Part B is to write the equation for a parallel line, so there are no solutions. And part C is to write the equation for a graph that goes through point 41, which is the solution for the system of equations. It's the intersection of the two graphs. The second PDF is for part B and shows what happens as the difference in the slopes gets smaller. So as the difference in the slopes gets smaller, the x-coordinate for the solution gets larger. It moves farther and farther to the right along the x-axis. So why does that happen? And then you reach the answer for part B, which is when the lines are parallel, there is no solution to the system of equations. And then when you move past parallel, that x-coordinate in the solution to the system becomes negative. So why is that happening? This is part B. The answer is different y-intercepts, but the same slope. That'll give you a parallel line, and there's no solution to that system of equations. The third PDF is for part C, and it shows how you get from this vertical line right here, and you move along the x-axis till you get to the answer, which is 4, 1 right here. So there's a single solution for the system of equations of this pink graph right here, and the graph for equation number 1, which is this black graph right here. And they intersect at this point, 4, 1. So they're actually PDFs from 3 through 10 have to do with part C. These PDFs show what happens as the difference in the slopes gets smaller. The x-coordinate for the solution between each of these systems of equations gets larger. It moves to the right along the x-axis. So the x-coordinate is getting larger until it goes past parallel, and the difference in the slope of these two lines is 0. And then the x-coordinate to the solution flips over to a negative value, and it starts to get smaller. So why is that happening? So this is part C. And here's the answer once again to part C. The fourth PDF has the 6 images and all 17 sets of those images. So it's huge. It's 129 pages long because I wanted you to see everything together. And so it has this vertical graph, and then it goes to a system of equations for a set. So this is the system right here. This is the second graph, the second equation, and this black line is always the first graph, the first equation. And then I show you the slope of the second graph. You already know the slope of the first graph. It's a negative 3/4. So I show you the slope of the second graph and the calculation of the difference in the slope between the first graph and the second graph. And then that difference on a number line. And then the calculation of x, taking the difference in the slope and dividing a negative 2 by that difference gives you the value of x, and then more detail on that calculation. And I go back to the Actually, this is the second image that shows you the slope again, just so that you can see where it came from. And then I go on to the next one. So this is the next set. The slope. So this would be 5 halves over 1, or a slope of 5 halves. The difference in the slopes between a negative 3/4 and a positive 5 halves. Using that difference, or showing that difference on a number line. Then the calculation of x, which is negative 2 divided by that difference. And then more detail on that calculation, so you just can see that, how you get to a decimal value. And then it repeats, goes back to the second image once again to show you the slope, and then it goes on to the next one. Now it's hard to see the patterns showing the image of each set each time. So the next PDFs separate out each image within a set. PDF 5 shows the difference in the slopes is decreasing, so that difference is getting less as I move forward here, and the value for the x-coordinate is increasing. So this slope is actually approaching this slope of the first graph, so that difference is getting less. This is the answer to part C, where it goes through 4(1). So this is the solution to the system of equations. And then that difference is getting less and less and less until it reaches parallel. And so there is no difference, so there is no solution, because these are parallel lines. And then it continues and it flips over to the other side where the x-coordinate becomes negative. So the difference in the slopes is decreasing as this line approaches the same slope as the first equation, or the graph of the first equation, and the x-coordinate is getting larger. So why does that happen? Reaches parallel, so there is no solution, goes beyond parallel, or beyond a difference of 0, and so now the x-coordinate is negative. PDF number 6 shows the lengths along the x-axis and the lengths along the y-axis that you would use to calculate the slope. So the slope of the first graph here is a negative 3 over positive 4, so it's a negative 3/4. The slope of the second graph that's in the system of equations is 5 halves divided by 1/2, and that's the slope of 5. This is the slope of 5 halves, and so on. So these are all positive slopes. Then it reaches 0, which has a slope of 0, goes beyond 0. So these are negative slopes, but the difference is a negative value. So this is a negative 1/5, and so it's a negative 3/4 minus a negative 1/5. That gives you a negative difference. So a negative difference until it's parallel. So now the difference in the slopes are 0. So this slope is a negative 3/4, and the slope of this line is a negative 3/4. So that's a difference of 0, goes beyond parallel lines. So now the difference in the slopes is a positive difference. So now you're taking negative 2 and dividing it by a positive number, so you're going to get a negative x-coordinate up here. This is different ways of calculating that slope. You can calculate the same slope. So this is a slope of negative 1, or you could use these lengths here, slope of negative 1. Different way to calculate the same slope, a slope of negative 3/2. Different ways to calculate the same slope, and so on. And so now this is a slope of negative 5, and so that difference is a positive value when compared to negative 3/4. So it's a negative 2 divided by a large positive number, and so this x-coordinate is negative. PDF 7 shows the calculation for the difference in the slopes. And this difference starts out as a large negative value, and it gets smaller and smaller and smaller. It decreases as the difference, of course, decreases between the blue lines and the original black line. And as that difference gets smaller, and it's a smaller negative difference, that means that the calculation of x gets larger. The x-coordinate gets larger. So the difference gets smaller, the x-coordinate gets larger as it approaches a parallel line with the black line. It's getting closer to the black line, and so now it's parallel. This is the parallel line right here. The difference is 0, so there's no solution. But right before that, the difference is a very small negative value, and so that means that x is going to be a large positive value. So the x-coordinate is going to be very large, and it's going to be positive. And then once this flips past this parallel line here, the difference is going to be a small positive amount, which means that x is going to be a large negative, large in magnitude, negative value. So it's going to be way up here, but that x-coordinate is going to decrease in magnitude as and approach the y-axis as this difference gets larger and larger. So now it's small, and then it gets larger. And so this difference, this calculation of x, gets smaller in magnitude and approaches the y-axis. PDF 8 shows the difference in the slopes on a number line. So this difference in the slope starts out as this is the slope of the first equation. The graph of the first equation is -3/4. The slope of the graph of the second equation is a +5. That difference is a -5 3/4. So a large negative amount, that means the x-coordinate is going to be a small positive value. And as this difference decreases, as those lines approach the same slope as the first equation, the graph of the first equation, this difference gets smaller, it decreases. That means the x-coordinate is going to get larger and has a positive value. So the difference gets smaller, the x-coordinate is getting larger. So that difference is a smaller negative value. The x-coordinate is a larger positive amount. Then it reaches the parallel line, or the difference is 0. So there is no solution. And then once it goes past a difference of 0, now that difference is a +1/4. It's a small positive amount. That means the corresponding x-coordinate is going to be a large negative value. And that's going to decrease in size, the x-coordinate, as the difference gets larger as a positive amount. So this difference is getting larger as a positive value. That means the x-coordinate is getting smaller as a negative amount, and it's approaching the y-axis. PDF 9 shows the calculation of the x-coordinate. So as this difference gets smaller, so it starts out a large difference between a -3/4 for the original graph and a +5 for graph number 1. That is a large negative difference. So -2 divided by a large negative value is going to give you a small positive amount for the x-coordinate. And that difference is going to decrease. So this difference is getting smaller. And as this difference gets smaller, then this x-coordinate gets larger. It's a -2 divided by a smaller negative amount. And so this x-coordinate is getting larger as a positive value. Until it reaches the parallel line, which the difference is 0. And this is undefined. There is no solution. And so now the difference is a small positive amount. So a -3/4 minus a -1 is a +1/4. So -2 divided by a small positive value is going to give you a large negative x-coordinate. But this difference now is going to get larger. It's moving towards, the lines are moving, the slope is moving towards the y-axis. So this difference is getting larger as a positive value, which means that the corresponding x-coordinate is going to get smaller as a negative value. So this is getting smaller, it's moving towards the y-axis. PDF 10 is the same as PDF 9, but just with more detail on this calculation to get to this decimal value for the x-coordinate. So showing you how I'm doing the calculation. Again, the difference decreases, the x-coordinate increases, then it flips to a positive difference, and the x-coordinate is a negative value, and that's going to decrease towards the y-axis. PDF 11 is the summary table of the information shown in Part C. So this is the original graph equation 1, which has a slope of a -3/4. And this is all the other graphs. And so all those other graphs have a decreasing positive slope until it gets to 0, and then an increasing negative slope beyond 0. The difference in the slopes is decreasing, decreasing, decreasing as negative values until it reaches a -3/4, and then it switches to increasing positive amounts beyond this -3/4. The x-coordinate is increasing, increasing, increasing as a positive x-coordinate reaches 0 here, undefined or no solution, and then starts to decrease as a negative x-coordinate as it approaches the y-axis. So there's a short separate video on this. PDF 11 also shows dividing 2. Now the difference in the y-intercepts is a -2 units. So it's useful to look at dividing those -2 units. So I just chose to look at it as just dividing 2. But dividing 2 by smaller and smaller amounts, and look what happens to the answer. Look what happens to the, in this case, which would be the x-coordinate. The x-coordinate would be getting larger and larger and larger in size as you divide by a smaller and smaller amount. So I'm going to go through this. There is a separate video on this showing how this division works. PDF 12 shows a choice that you have when you set up the algebra. So you can either choose to work with all the x terms on the left side of the equation like this, or choose to work with the x terms on the right side of the equation like this. That choice will determine whether or not you work with negative numbers when you calculate what x is, or positive numbers when you calculate what x is. Either way, you're going to end up with x equals, in this example, x equals a positive 4 4/5. And there's a short video that goes through this. Finally, PDF 13 is a supplement that shows writing equivalent equations. So part A of this problem set is showing or writing equivalent equations so that you have infinitely many solutions. They're the same line. And so if you do that, you have to end up simplifying both equations so that you can show that they are equivalent. So you're going to use properties of mathematics. And I have a video that shows this. And you also have this PDF where you can go through this much more slowly, but you get down to the point where x equals x. And that shows you that these two equations are equivalent and you have infinitely many solutions. Whatever you choose for x is going to be the value for x in the second equation. And this is just showing that those equations are equivalent by graphing, so you end up with the same line. Now I took the easy way out. I just wrote an equivalent fraction as the slope. And so I wrote two different equations. These have infinitely many solutions. But there are different ways to write equivalent equations. And I think more interesting ways and better ways to understand the algebra. And so I'll go through this. This is a second way, using the distributive property. And this is again using the distributive property. You often see this, where they'll write this form up here, a -3/4 times x plus 4 plus 7. Now nowhere does it teach you how to do this. And so I'm going to try to do that in this video with this PDF.